Ramya, will anybody join now? So have you guys practiced the problem given?
Yes, sir.
Any queries regarding that?
Sir, we are having some doubts in that, sir. We don't know whether the answer is right or not.
Better please forward it to my looking team to know. Then I'll let you know.
Okay, sir. Shall I send it now, sir?
Yeah, you can find no issue. What about others, guys? Frankly speaking, as I'm telling you, I'm just giving you randomly these questions, so I don't have any final answers to speak about. That's why please verify among yourself, and if you have any doubts or if answers are not matching, then we are free to discuss about it. Any doubts regarding conceptual wise? Concept wise, is there any doubt regarding the slope deflection method?
In this, at point B, when we are taking the equilibrium equation, we have to take BA, BC, and BD, right, sir?
At point?
At point B.
Yeah.
MBA plus MBC plus MBD, whereas MBD we should take as minus 20. That is the moment in that particular member.
Yeah, right.
Okay, sir.
Now let's see.
And the moment about AB is equal to 0, moment about CB is equal to 0. Is it right,
Yes.
sir?
As the principles, right. Similarly, in the same way, can you tell me if you want to solve these frames by using the slope deflection method, how many number of unknowns you will consider? And what do you think? The same problem, if I want to solve it by using slope deflection method, how can I approach it?
So there will be a deflection.
Yeah, what okay, fine, that's fine. Okay, now let's see here. Given here, let us say A, B, C, D. Now, if you are talking about the frames, what will happen? There is a possible of sway mechanism is possible. What is meant by sway? Lateral drift of the frame. Either it's due to any wind loads or any lateral loads, maybe because of earthquake, maybe. So whenever if the lateral load acting like this, then obviously you can understand, right? Along the direction of the load, this frame will sway on the right side direction. But as you can see here, sway means nothing but drift of the frame, either to the left or right. Now, as you can see in these two cases, which one is symmetric? By looking at the frames itself, can you identify?
First one is symmetric, sir.
First one is symmetric. As it is a symmetric, then in this case, and there is no horizontal or there is no lateral force, we can say that there will be no sway. Sway will be equal to 0. Sway will be equal to 0, matlab, this point, there won't be any lateral drift along right or left. There won't be any lateral drift along right or left. So if I draw the deflected shape, as it is a fixed support, the slope will be equal to 0. Fixed support, the slope will be equal to 0. Then the deflected shape might be like this. As you can see, as it is a rigid joint at B and C, the angle between them, even after the deflection, 90 degrees, they will maintain the 90 degrees. Just like here, before the deflection, what is the angle? Even in this frame, 90 degrees. Even after the deflection, it will maintain the same. That means the slope of the deflected members are same. So in this case, if you want to solve it by using slope deflection method, the number of unknowns you have to consider, they are nothing but rotation at B and rotation. What about in the second case? Is it look like symmetrical?
No, sir.
No, it's not a symmetrical, right? So if it is not a symmetrical means, what about the loading? Loading is symmetrical?
Loading is symmetrical, sir.
Loading is symmetrical, but the frame is not symmetrical, right? Now, even the frame is not symmetrical, sway can occur. Now, in which direction the sway can occur? Further, the question will be least stiffness. Wherever you are having the least stiffness, along that side, the frame will sway. Now, look at the column AB and look at the column CD, which is obviously, even by looking at the diagram, we can say which one is having more length. Column CD is having the more length. Can you somehow tell me in which column you will have the more stiffness? Shorter column or longer column?
Shorter column, more stiff.
Yeah, even you can say that shorter columns will take the larger loads compared to the longer columns. Or you can say that the stiffness will be
More.
If you're talking about lateral diff, then the stiffness will be around 12A by L square, or somewhere around inversely proportional to L.
Yes.
As your stiffness is inversely proportional to L, the column CD is having the larger length. That means it will have the least stiffness compared to the column AB. That's why this frame will sway towards the which side? To the shorter column side or to the longer column side? To the longer column side.
Longer column.
They will happen to the right side. Usually, as I told you in the earlier classes, that if you are talking about the frames, generally we will neglect the axial deformation. That means there won't be any axial deformation in the member BC. Generally, the magnitude is very, very, very much smaller in magnitude. So that's why the point B will be moved by the same amount, and C will also move by the same amount. So that's why the reflected shape will be, even though it looks like this magnitude is larger, but if this is a magnitude of delta, and this is also having the magnitude of delta. So if you want to solve this case by using slope deflection method, then how many unknowns you have to consider? You have to consider rotation at B, you have to consider rotation at C, and as well you have to consider the drift magnitude. Now, by looking at the delta itself, where do you think the fixed end moments develop? In addition to the loading, because of the loading, fixed end moments will develop at B towards C, at C towards B, we will write it down. In addition to that, because of this drift, what do you think where we will obtain the fixed end moments? What are the fixed end moments because of the sinking of support? Delta, imagine if there is a sinking of support. What are the fixed end moments? If you guys remember, 6CA delta by L square. Now, imagine this AB as a beam. Now see, B, I can say, if I take only AB, and in the second case, if this is sunk by an amount B, what do you think? It is similar to that case or not? That means, in this case, we have to consider the fixed end moments because of the lateral diff. Here, we will consider 6CA delta by L square at this joint and at this joint. Similarly, along the member CD also, we have to consider. Here, my point is to say that if there is a drift, we have to consider that unknown also in the slope deflection method. And we have to consider fixed end moments corresponding to it. Is it okay about this second case too, or any doubt? Now, can you tell me sway will occur or not in this case? It is a straight column. Don't think that it is inclined column. Just pardon me for my drawing. This is a symmetrical frame or unsymmetrical frame?
Symmetrical, sir.
Symmetrical.
By shape, it is symmetrical. By considering the supports, it is
Supports,
unsymmetrical.
it is not symmetrical.
If we are talking about the frame, we have to consider supports also. If supports are not same, then it's not symmetrical. It is unsymmetrical only.
Yes.
The loading is symmetrical, but the frame is unsymmetrical.
Okay, sir.
That means that A it is a in support and at D it is a roller support. Sorry, fixed support. What do you think? Which one will have the more stiffness? To the fixed support will have more stiffness, or to the in support?
Fixed support will have more stiffness, sir.
Have the more stiffness. A will be larger. Here, A will be least compared to this case. So, as the stiffness of the left column is lesser, then obviously this will sway towards the left. So, in this case, the sway occur towards the left. So, just again, just like in the previous case, you can draw the here the rotation will occur. So, that's why there is some rotation at joint as it is a pin support. Here as it is a fixed support, as I'm joining with vertical line. So always remember these points. While drawing the reflected shape, you have to draw such that that should satisfy the boundary condition. As you can understand, as it is a fixed support, I have drawn this line with slope is equal to 0. As it is a pin support, I have taken with inclined line so that rotation will exist. So this amount is also delta, and this amount is also, even it is horizontal, it is not inclined. Imagine it is a horizontal. Sway will occur or not?
No, sir.
No, right? What about now?
Yes, sir.
Obviously, even the frame is symmetrical. Even from the loading itself, we can understand, right? Now, sway will occur,
No, sir.
No, sir.
right? Now, what do you think? Sway will occur or not?
Will occur, sir.
Will occur? Think about it and tell me. If it occurs, can you please tell me why it will occur? First of all, tell me about this case 3, and then let's talk about case 4. First of all, tell me about case 3. Will they occur in case 3? If you want me to about load condition, let us say exactly, or it doesn't matter. Will sway occur? Why you're taking so much time? What is the reason?
No, sir.
Symmetrical? It's not symmetrical. But what happens? Look at the support E. Even though because of the frame is not symmetrical, even though it will sway, what about the support E? Will it allow the drift? Look at the support E and tell me, even if this frame tries to move towards the left side, will support E will allow the drift?
No, sir.
No. That's why in some cases, even though the frame is not symmetrical and the loading is not symmetrical, supports plays a major role. Just like here, this support will not allow any sway. That means this is a sway will be equal to 0. So if you want to solve it, how many unknowns you have to consider? You have to consider slope at A, you have to consider slope at B, you have to consider slope at C, you have to consider slope at E. So if you want to solve it, you have to consider 4 unknowns. Instead of this roller support, if I replace with this type of support, now what do you think? Sway will occur or not?
Yes, sir.
That's why, because as it is a roller support, it can freely move along at that
It
direction.
will move.
That's why sway will occur if I replace that support with roller. Now look at the case 4 and tell me, sway will occur or not?
No, sir.
Why? Because as you are looking to say, so first of all, let me hear your reasons. Why the sway will not occur? What do you guys think?
Even though if it tries to move, that F support will not allow it to move, sir.
Then what about CB and ED? First of all, tell me. So let me talk about this case first. In this case, support reactions will be same or different? Whatever the reaction,
Same, sir.
as they're symmetrical, obviously we can think of the same, right?
It will be same.
Now, tell me in the same concept, what do you think the moments at E and the moments at E? What do you think? These two will be same? In general, most of the time I can say that 90% these will not be same. Why? Because if you look at A and if you look at G, and that's why maybe the reason I can't say or I don't say that the moment at B and the moment at E will be same. There might be different. So in most of the cases, I can tell you that in this case, the sway can be possible in the upper portion. Matlab, the sway is possible here. That won't possible here. Why? Because the support F will not allow. But there is a possibility of sway that can occur along the upper stories. Why? Because the sway is restrained at support F only, but not at the upper stories. And this type of cases specifically, we cannot specifically argue that whether the sway will occur or not, but we can say in terms of chances. Okay, in this problem, if you guys want me to say, I can say that there are more chances that sway will occur. But if you talk about this case, 100% the exam, they will not ask you these type of problems, but still we should try to visualize the things and at least try to get the idea whether roughly whether it will possible or not, even though it won't be said exactly. Now, sway will possible or not?
Yes, sir.
In which direction it is possible? It is not correlated with any of the thing. Now it is about loading, right? Let me just tell me in general in which direction the sway might get occur. Just give me a
B side, sir.
to the right, to the left side.
Towards right.
Why so? Why it will occur towards the right?
Because at left side, there is loading, sir. So because of that, it will move towards that side.
Yeah, but if you want to idealize, imagine cut a section at the middle, and you can see if I draw the loading part separately, what do you think in which direction it will deflect? If there is a half cut part, obviously, if you see the deflected shape, I can see that the deflected shape might be like this. So whenever it is not possible to directly identify, just like in this case, cut a section in the middle and identify. Or wherever the least, here as you can see, the load is occupied on the left side portion. So in that case, the sway will occur on the right side. If more load is occupied on the left side, then we can say that the sway will occur on the left side, just like vice versa. So these are the some possible cases where we can identify whether the sway will occur or not. There is a hinge here, and if there is a loading, what do you think? Similarly, whether the sway will occur or not, if sway is possible, in which direction it is possible? Do you think?
Towards left, sir. See.
If you are saying towards left, what is the justification that you can give?
Hinge
should
will not allow the movements, sir.
So if there is a hinge, you have decreased the stiffness or you have increased the stiffness.
Will increase, sir.
If there is one side there is a rigid joint and one side there is a hinge, where you will have the more stiffness, to the rigid joint or to the hinge joint?
At rigid comparatively.
At rigid comparatively. So where is the least stiffness side? Obviously at the inside. So obviously, as we have discussed, towards the least stiffness, the sway will occur. So in this case, the sway might occur on the right side, isn't it?
Okay, sir.
Now, what do you think? In which direction the sway will occur? To the right side or to the left side? This we can say.
Left side, sir.
Left side, why? Because
There is a hinge support.
In this case, there are two cases, right?
Yes,
One
sir.
thing is that the frame is also unsymmetrical, and
Loading.
second thing is that
Loading
load is also First of all, forget about the loading. Look at the frame and tell me, because of the frame, where the sway can occur, to the left
Towards,
side or to the right side?
towards left.
Towards left. Look at the loading and tell me where the sway direction can occur,
Towards right, sir.
towards right or towards left?
Towards left, sir.
Towards left. So whenever there are two unsymmetrical conditions, like either with respect to the loading or with respect to the support conditions, we have to visualize those two and then we have to get the conclusion. Even now in this case, either because of the loading or because of the frame unsymmetricality, on both cases, the sway is possible on the left side. So overall, you can judge that can occur to the left side. But
So what about if the loading is on left side of the frame?
what about if there is a load here with a magnitude of 2p? For that case, because of the frame, it is unsymmetrical. Can you tell me? Because of the frame, already we have discussed.
Left.
Now, because of the loading, what do you think? In which direction the sway might be possible?
Towards right, sir.
Towards side, because of the left side, the load is larger in magnitude. So here it will be right. On one side it is left, on one side it is right. So in this case, it's not exactly right. Either the sway will occur on the left side or the sway will occur on the left side.
It is.
But even the sway might be zero also. If the unsymmetricality due to loading and the frame conditions, if they balance each other,
Okay, sir.
then there might be possibility of zero also. But so just like there are some cases where we might not able to decide in which direction the sway can occur. Clear? So these are some possible cases where the sways can occur, and also the cases where we cannot decide. Is it okay?
Sir, can you draw the deflected shape for this frame, sir?
This frame, that's why I'm telling you, I cannot, isn't it? Why? Because I don't know, right, in which direction it will occur. If I truly know in which direction it will occur, then only I can. It doesn't matter about the loading. Don't, if you are drawing the deflected shape, always think about the drawing the slopes exactly. Just like here I'm drawing you here. Wherever you want to draw, just make sure that before the deformation and after the deformation, the angle between them will be 90 degrees. I think here it will start like this instead of this, because the angle should be 90 degrees. And here the angle should be 90 degrees. As it is a fixed slope, the slope should be 0. As it is a fixed support, the slope should be 0. Can we move further?
Yes, sir.
Let's come back to the moment distribution method. I have already told you, right? It is also a stiffness method, and also I have told you why it is the iterative method in the previous classes. Right? So whenever you think of the moment distribution method, the first thing it should identify your mind is to find the distribution factors. So for the distribution factors, you should know first of all what are the stiffness of corresponding members, and also you have to identify what are the carryover moments, or we can say what are the carryover factors. So if you know these two, then based on this we can find the distribution factors, even if it is entirely related upon this. After that, the iteration process will go on, that we can discuss in today's class itself. So for that, let us talk about first of all, what is the stiffness? Now, let us say this is A and B. Now, what do you think the deflected shape will be? Here the slope will be possible, and here the slope will be 0. Before moving on to discussing about stiffness, can somebody tell me what is mean by stiffness? Or what is the unit of it? How do we define the stiffness? Let's say if I'm talking about 10 Newton per meter, if I'm defining this, can you tell me in terms of words how we will explain this? Or what is the formula to get the stiffness?
Force by
Load uptime per unit meter.
Yeah. So if you want to talk about the stiffness, you should say that force required per unit deflection. That means what is the known quantity and what is the unknown quantity. We know the deflection, unit deflection. That means at any point, let us say if I'm defining my stiffness as 10 Newton per meter, that means if the system wants to move a displacement of 1 meter, then how much force I should apply? I should apply a force of 10 newtons. So if somebody asks you from now onwards what is the stiffness, don't say the force by delta, you should say that force required per
Unit deflection.
unit displacement or deflection, right? Similarly, let me tell you what is the flexibility. In the same words, we can say they are inversely proportional to each other, 1 by k. That means here I can say delta by f. That means what you can say. Let's say if I'm talking about it is 10 meter per Newton. What do you think? Here what we are saying? We are saying that force required per unit displacements. Similarly, how can we define the flexibility? You can say that if I apply a 1 Newton force, how much force will be happen or how much displacement can happen?
10
meters. So vice versa. If it is a stiffness, we say that if you want to get a deflection of 1 meter, how much force we have to apply? If you are talking about flexibility, if I apply a force of 1 Newton, how much deflection is possible? Is it clear? The difference between the flexibility and the stiffness? So
Yes,
we often more use these two terms again for coming classes. Okay. Now, similarly, if I'm going to find the stiffness at A, what about the far end I'm looking at? Far end I'm talking about it as a fixed support. If far end is fixed support, or we can say it is a continuous. If the far end is fixed or continuous, then force required to get unit rotation. Here what I am saying, theta A is equal to 1. What is the, in this case, see obviously I told you, right? If you apply the forces, you will get the deflections. If you apply the moments, you will get the rotations. So if I am talking about the deflections, I will talk about the corresponding forces. If I talk about the rotations, I'll talk about the corresponding movements. So here, if I'm talking about what is the stiffness at A towards B, what I can say, if I'm talking about KAB, that means to get the unit rotation at point A, how much movement we have to apply? The movement we have to apply is nothing but a 4EI by L. So the KAB, that is nothing but 4EI by L. Clear? Now, can somebody tell me what is the stiffness at B towards C in this case?
zero, sir.
What is 0?
B towards A.
Stiffness is 0. Stiffness. So there.
2E by L, sir. Half of
That you are telling because by identifying the carryover factors, but
Yes,
I'm
sir.
asking you in generally. I apply a moment of 4EI by L at point A, obviously because as there is a foreign and it is a fixed support, half of the moment will carry over. That's what we have discussed.
Yes, sir.
Loading and everything. What about ABA? What about the rotation at point B?
Rotation is 0, sir.
Yes, sir.
If rotation is 0, then what about the stiffness? I'm talking about the stiffness there. What is the formula of stiffness you can see?
Force by deflection.
If deflection or rotation is equal to 0, what about your stiffness then?
0.
Infinity.
Delta is inversely proportional.
Yes, sir.
If delta is inversely proportional, then how you will define the stiffness? K will be equal to force by, in this case, m by theta, I can write it down. What is the theta? 0. If theta is equal to 0, then what about the stiffness then? Infinity, right?
Yes, sir. Yes, sir. Infinity, sir.
That means if somebody says the stiffness is infinity, what does it mean? It means that you are talking about there is no possibility of displacement occurs at that point. Or we can say that you need a infinitesimal force to get the displacement at that point, vice versa. Either you can say that your displacement is very much 0, or you can say that we need a very large force. So you can say anything is possible. So you can say that, as I told you, again in this case we'll carry over factor, that is nothing but a movement at the rate far end divided by movement at the rate near end. Now, if you are applying a movement at the near end, 4A by L, obviously half of the movement will transfer here. So how much it will be? 2EI by L. What is the moment at the near end? It is nothing but a 4EI by L. What about the moment at the far end that is generated? That is 2EI by L. That means what about the carryover factor? That will be equal to 1 by 2. That means if your far end is either fixed or continuous, then what is the carryover factor? 1 by 2. I think we have solved this problem in the earlier classes. If you guys remember, we have solved the proper cantilever case. What if in this case? How about the reflected shape? A, B. In this case, rotation. Theta A is equal to 1. So, now if you are talking about KAB, what is the far end? B. Now in this case, you are talking about if your far end is pinned, then you need a stiffness of 4EI by L. That means if you apply a moment magnitude of 3EI by L, then the support A will rotate by unit rotation. In this case, as the far end is pinned, there is no movement will carry over. In this case, if I talk about carry over factor, that will be equal to 0. If your far end is pinned, the carry over factor is 0. Here, now imagine that at A, if I want a slope of 2 radians, sorry, at point A, if I need a slope of 0.5 degrees, can you tell me how much moment I should apply at A?
0.5 EA, sir.
I need to get a slope of 0.5 degrees, then how much moment I should apply?
Half of that,
Tell me the magnitude.
1.5, sir.
1.8 well, is it right? Three of you. Is it right or wrong? 1.5 or anybody disobey that? See, I'm telling you, you have to much concentrate about the units. What do you think the units of slope that we usually consider? What is the unit of slope? So we have discussed so many problems, rotations. What do you think the unit will be? What is the unit? Unit of slope.
Degrees, sir.
Degrees.
1 degree rotation only, no, sir, we used to say.
We have to talk about radians.
Radians, yes.
Degree is the primary unit. Radians is the secondary unit. So whatever you mention in the radians, that won't be considered as a unit, as it will be a secondary unit, and that means the magnitude is very, very less. Whenever you want to mention the slopes, you have to mention with respect to the radians. If you are not mentioning it as a radians, then you are done. That's why even at this from starting itself, I have been telling you guys that units are very, very, very important. Even though your approach is correct, if you are not using the proper units, then you will end up with the wrong answers. Just like here, you end up with 0.5 into 3I by L, 1.5I by L is the wrong answer. Why? Because you have to consider the unit as radians. Now, convert that into radius and tell me. I just want to see how you will convert into radians. What is the correlation?
Pi by 180, sir.
A kilonewton meter is the unit of moment, right?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Now, as you can see, if I want to find out moment at A, can I say that my stiffness at AB into rotation at A? That's what I should write, isn't it? That's what the unit of, what is the stiffness from the M by theta? What is the unit here? Can you tell me? What is the unit of E here? E. What is the unit of Young's modulus?
Newton per mm square.
Sir.
What is the unit of I? Moment of inertia?
Mm power 4
1 power 4 divided by, what is the unit of length?
meter.
That means what is you will end up with Newton.
Newton meter.
If you
Newton
want,
mm.
yeah,
Yes.
if you consider delta in degrees, here the unit will be degrees. That means your moment unit has become Newton mm degrees.
Degrees.
Now, this is the primary unit, you should not define. So always you have to consider this as the radian. As it is in secondary units, it won't count in the unit. That's the unit of will come Newton mm.
Okay. Sir.
Is it okay now?
Yes, sir. Yes, sir.
Sir.
Now, let us talk about this method. Now, what do you think? What is the stiffness of AB? Whether can we define or we cannot define, or how do we express here? KAB.
It cannot be defined, sir.
Far end is free.
If current is free, see, even if I apply, is it stable first of all? If I represent,
No, sir, not stable.
not stable, right? That means even I apply little force here, even if I disturb it by little amount, then that's why here we can say that as you apply little force, that's why the stiffness will be equal to 0. One is related with stiffness is infinity. That means deflection is not possible. Now imagine K will be equal to, I am saying it as m by theta. First case, if I am talking about theta is 0, I am talking about my stiffness is infinity. What about my theta is infinity? What about my stiffness? 0. Mean the rotation is infinity. That means either it is very not stable or very smaller force required.
Okay.
So if KAB is equal to 0, that means either it can be unstable or very much smaller force is required to apply the rotation. So that's whenever RN is free, usually we don't consider any rotational stiffness. Yeah. The same logic, let us continue to discuss an example. Now, if I apply a moment here, a magnitude of m. Now, can you obviously, if I am applying at the joint directly, I can say that is restricted by all the corresponding members. Or I can say that if there is concentrated moment at joint, I can say that the moment will be distributed to the corresponding members. All right. So in this case, if I apply a moment M at joint B, how much will be taken by member BA? How much will be taken by member BD? How much member will be taken by BC? If I add moment at all the joints at B, how much I should get?
0, sir.
If there is no load at that acting at that joint, in this case, there is a moment acting at the joint, right? If there are external moments are acting at the joint, then the summation of moment should be equal to whatever the applied. Think of in the sense like this. I'm applying some moment at joint B. If you apply some moment, will it be distributed to the corresponding members? Obviously, it will distribute to the corresponding members, right?
Yes, sir.
So, imagine I'm applying 10. Out of 10, let us say BA is taken 3, BD is taken 6, and BC is taken 1. So if I apply moment of 10, the BA is taken 3, BD is taken 6, and BC is taken 1. Whatever the moment you will apply, or whatever the moment that is generated at the joint, that will be distributed to the corresponding members. How they will distribute, that will based on the corresponding stiffness. So wherever there are moments, in this case concentrated moments, you have to identify that what is the stiffness of the corresponding members. Now you can say what about my stiffness of BA at B towards A? What is the far end A? Imagine in all these cases EA is equal to constant. Whatever the stiffness of member BA, about the far end?
3A by L, sir.
As far end is A and it is a pin support, the stiffness is 3I by L. What about D? Far end is D. So what is the stiffness? 4EI by
4A by L.
whatever the stiffness of C.
0.
What about C? Far end 0. So a joint What is the total stiffness at the joint? If I talk about my stiffness at the joint B, about the total stiffness corresponding moments. Sorry, 3A by L, 4A by L plus 0. How much you will get?
7
3A by L. Is it okay? Imagine if I am C, if there is a spring here, if there is a spring here, if there is a spring here, and imagine I have applied a load here, and imagine in one case there are two springs. If I apply 10 Newton force here, this will be distributed to two springs. If I apply here, distributed to the three springs. So just like here at joint B, for the corresponding members, it will distribute it to the three members. But if you write the stiffness of those magnitudes, BC is not carrying any stiffness. That means BC does not take any moment. So which members will take? Member BA will take and member BD will take. According to how? According to their stiffness proportion. Right? Now, can you tell me what is the stiffness proportion of BA? Total at the joint B, what is the total stiffness?
7 L.
Imagine at BA is how many parts?
3
Three
parts
parts.
divided by
BD is
7.
how many parts? 4 parts. That means total how many parts? 7. Out of the 7, how many parts are taken by BA?
3 parts.
3 parts. That means what is the distribution factor for the member BA? 3 by 7. What is the distribution factor for BD? Out of 4, 4 by 7. That means if you apply a moment M there, how much moment will be taken by BA? That is nothing but 3 by 7 of M. How much moment that will be taken by BD? 4 by 7 of M. How much moment is taken by BC?
0.
0. If I draw the separately, so here what is the moment we develop? 3 by 7 of moment. Talk about vertical number, how much it is a develop of 4 by 7 of M. If you talk about this, no. Again, if we add these three values, how much you are getting? That is what the applied moment that you are applying there.
Yeah.
Clear how the things will work? The
Yes, sir.
visualization of the thing. Right?
Yes, sir.
For the distribution is talking about distribution factor is nothing but a stiffness divided by total stiffness.
Yes.
Okay.
Yes, sir.
Now imagine at joint B there are two members BA and BC. Stiffness of BA is 3 by 7. Stiffness of BC is 4 by 5. Can you tell me what is the distribution factor for this quickly? What is the distribution factor for this? How you will do it? Imagine, you already know, right? I just want to see your approach of calculation. What is the distribution factor for BA and BC and how you will find it out? Or even let us say that here it is somewhere around 23. Can you tell me how you will do it? I just want to, you obviously will use calculus, but how you will do it? That's what my next.
3 by 7 plus 4 by 23, that is total stiffness.
Okay.
And
again you will
the BA part is 3 by 7 divided by the total stiffness.
But can we somehow reduce that calculation in a single part? Obviously, you will use calcs, isn't it?
Yes, sir.
Can we somehow reduce that
part. How can we reduce it in one step? How can we write it down?
Ratio.
Yeah, ratio, right?
Yes.
It's just that imagine 23 by 23, 7 by 7. If I write this, is there any problem?
No, sir.
No, right? So total how many parts? Now, how do we generalize this? Now we are talking about right total 3, 4. We are talking about total 7 parts, 3 by 7 and 4 by 7. Is there any possibility to write in that way in the calculation board? How can we improve this? Okay, what do you think is that? Just think about this case, okay? Instead of finding these two, what is the some shortcut that we can apply? If not, I'll discuss with tomorrow. Just think about it a little bit in the form of this fraction. You might get
Yes.
something, right?
Yes, sir.
I can say it right now, but I need you to guys to think about it. Now, my question is, how much moment I should apply here to get rotation at B is equal to 2, or I can say 2 radians. If I want to get the rotation at B is 2 radians, how much moment I should apply? Can you please think of this same, just like the previous case? What is a joint B? It is a continuous support, isn't it?
Yes, sir.
If it is a continuous support, what is the slope in the corresponding members in BA and BC?
Should be same.
It will be same, right?
Yes, sir.
So to get the rotation at joint B, obviously the both the members should rotate, isn't it? The BA should also be rotated by some amount. The BC should also rotate by the same.
Same.
That means we have to apply a moment magnitude such that both the members should rotate an amount of 2 radians. Now, let us talk about BA. If you think about BA and to get the unit rotation or to apply the unit rotation in the member BA, how much moment we should apply? Think about this whole part. Now think about simply, and if you want to rotate B by an amount of unit rotation, how much moment you should apply? What is the
Radians, sir.
what is the foreign? In support, if
It's
it is
plus
Fahrenheit inch. So if the Fahrenheit inch, how much moment we should apply? 3 E I by L.
L.
Right? Already length is given. So much thing if you think of AB, imagine if you want to rotate by an unit rotation, how much we have to apply?
3 A by L.
Now what is our question? It should rotate by 2. Then how
Yes.
much moment we should apply? Multiplied by 2. 2 EI. Similarly, look at for member BC. Then how much moment again we have to apply? Again, what is the foreign? Pinch. Again, 3EI by L. Length is given again 3. That will be equal to EI. If you want to rotate by 2 radians, then multiply by 2. Now, what is the total moment I should apply at joint B such that rotation B will rotate by 2 radians? What is the answer then? For BA have
3A, sir.
calculated independently, 2A. For BC have calculated independently. That's what we are talking about. If the member B should rotate by an amount, BA should also rotate, BC should also rotate. So the total moment is nothing but a moment required for both the members to rotate by the same amount. So add the corresponding values to rotate member BA. How much moment we required?
2
2
EA.
EI. To rotate member BC, how much moment you should require?
2
2
EA.
EI. So total how much it will be?
4
4
EA.
EI. So if you apply a moment of magnitude 4 EI, then joint B will rotate by same
2
number, right? Now, as I am telling you, imagine if you apply a moment of 4 EI at joint B. Can you tell me how much moment will be taken by BA? How much moment will be taken by BC? If the lengths are 3 meter, what is the moment at B towards C? What is the moment at B towards C? Why are you taking so much time? Take your time and tell me at least. What is the moment at B towards A? What is the moment at B towards C? What is the difficulty that you guys are facing? Have you understood the question first of all?
EA, sir.
How much? 2
2 EA.
and two EI and 2 EI.
And 2 EA, sir.
Look at the book. Can you please understand the difference of these two cases? What is the first case that I have given and what is the second case that I have given?
In first case, radian is given. Using the radian, we have to find the moment.
And in second case,
In second case, moment is at the joint is given. How much of moment is transferred to the
can you identify the difference of these two? In first case, I have given you the radian and I have asked you to find the moment required. In the second case, I have given you the moment and I have asked you to find the what is the shear between the members. That means if we apply the moment at the joint, how much will be taken by the corresponding members. Now, I don't know why you guys took so much time. See, you see in the first case, member BA, how much force we have applied, member BC, how much force we have applied, both sum it up. That's where we have got the 4EA, right?
yes, sir.
That means directly, I expected that you guys directly will say 2EA based on this. I have just given you the same example, but I that's it. One case I asked you to indirectly come from member and then add the value. First, add the force required for one member and then force required for another member. And then I have asked you to add those two values. Isn't it? That's
Yes,
where you are getting 4EI. In the second case, what I am giving you, I have given you one value and I have given you separate it into the corresponding members.
yes, sir.
Are you identifying the logic there?
Yes, sir. Yes, sir.
Yes, sir.
Now, even in the second case, you can find the rotation at B. Can you or cannot?
Yes, sir.
Tell me, let's say if I give some random magnitude of 20. I have given you in the second case, I have given magnitude 20 at joint B. Can you tell me how you will say that or how you find the rotation at joint? Is my question clear?
Moment
Now,
by stiffness, sir.
I am giving you the moment at joint BS 20 Now I am asking you, what is the rotation at joint B? How you are going to find out?
Moment divided by stiffness.
Moment divided by stiffness.
Stiffness.
And what is the stiffness we will consider there?
Stiffness
EI
is
by L.
3 by L, sir.
How much?
3 by L.
3?
EI by L.
EI by
Stiffness.
I'm not talking about single member, right? I'm talking about a joint.
Ah, yes.
No, I'm not.
Joint. Yes, sir. Joint is total.
No, forget about that. We can visualize this later on. But let's go back to this case. And what is my rotation at B?
Can you quickly tell me? Any answers? Come on, guys.
Moment divided by the total stiffness, sir.
No, I just need I have given you all the values, corresponding values. I just need the answer only. What is my rotation at B? I don't want to hear anything else. What is my rotation at B? Just try to think about it. We have discussed all the things that is required to solve this problem. Just apply the logic that we have discussed.
100 by EI, sir.
100 by
EI.
100 by EI. Let me think about it. Hundred by
EI.
no. But you are close, but still think about it. Why not 100 by EI? Any others? What about other two?
1 minute, sir.
Yeah, carry on.
Sir, it is 42.85 by EI.
How much? 40?
42.85 by EI.
Oh my god, not so accurately. Okay, forget about it. And how you guys, those who said 100 by EI, how you have got it? Can you explain us?
Theta is stiffness by. Sorry, moment by stiffness, sir.
Stiffness, right? What is the stiffness?
Stiffness at B is 7 EI by L.
Okay. What is the length you have considered?
Length is 3 plus 4, 7.
See here the mistake. That's why given C. You look at the member BA. It is given as 3. Look
Yes,
at
sir.
member given as 4. That
Yes,
means
sir.
you say 7A, right?
Yes, sir.
So that's where the mistake in this problem is. Those who got around 42 something, I will solve this also or any other something differently. So the point is, as I said, moment divided by stiffness, as you guys are right. And for
Yes, sir.
there are two ways to find the rotation. One is find out the total rotation, find out the total stiffness at that joint and then moment by total stiffness. And that will be your answer. And in the second way, you can find out what is the stiffness of one member and then you can find out. Again, in any way, you will get the same answer. It should be same. Like here 100 divided, we look at the member BA. What is the stiffness of that member? 3
by
what
L,
about
sir.
the length there?
By L.
3 is given.
3.
E.
Either gets cancelled, EI. Look
Yes,
at the member BD.
4
What
EI
is
by
the far and support 4A by L? What is the length given?
4.
4 gets cancelled. What is the stiffness? EI. What about for member BC? There is no, isn't
No,
it?
yes, sir.
Look at the member BA is also stiffness EA. Member BD stiffness is also EI. So what is the stiffness? 2EI.
2 EI, sir.
Now what about the rotation then? 100 divided by 2E equal to 50 by EI.
EI.
Okay. So whenever there are concentrated moments are acting at points, simply can solve the trick by using this concept of here.
Yes, sir.
Hope you guys have got an idea. Now, so if you want to solve this by using moment distribution method, so the first thing you have to do is find out the distribution factors. Now, as you can see, intermediate joints are there only one B. So for member B, we have two corresponding members BA and BC, as we have discussed. For BA, what is the stiffness? Let us say EA is equal to constant.
Or EI by L, sir.
A by L, A by L. Length is given as 4. For
4,
BC,
3 by
3 by L. Length is given as 3. EI and
equal to
EI. Then what you guys should do? Like if you are solving in state exams, what you should do? You have to find out total stiffness. You will write down here as 2EI. And then you guys will talk about distribution factor. That is nothing but stiffness by total stiffness. EI by 2EI. And then you will write it down 0.5. You will write it down 0.5. But if you are solving through gate, directly you can obtain these values. Right. Now, what is the next step? Fixed end moments. What is the fixed end moments at A towards B? What is the fixed end moment at B towards A? Similarly, what is the fixed end moment at B towards C? What is the fixed end moment at C towards B? Someone quickly tell me these values.
Sir, M of AB is -5, sir.
-5
-5
+5.
+5 with 30
minus
-30
-7.5.
-30 or -7.5.
30, sir.
Double L square by 12, right?
Yes, sir.
How much you have considered this one? 10
Yes, sir.
minus
7
30.
7.5, sir. Sorry, sir.
Don't always be careful about the units. I'm not asking you to write at every step, but while whatever the values you are finding, make sure that you will consider the proper units. So what is the next step that you guys should do? Now I'm telling you, I just write down the distribution factors here. What are the distribution factors that you have found? 0.5 and 0.5, right? Now, what about the fixed end moments that we have find it out? At AB towards B, how much? We have written it as -5. Here we have written it as a +5. Here we have written it as a -7.5. Here we have written it as a 7.5. Right? So first of all, we have to correct these fixed end moments from the support conditions. So first of all, we have to release the moments. That means look at here. At joint B, look at the joint C. Will there be any moments develop at that joint?
No, sir.
No, that will be 0. But we are representing the fixed end moments, isn't it?
Yes, sir.
As we are representing the fixed end moment, first of all, we have to neutralize this. How can we neutralize this? Initially, we are considering a clockwise movement, but actually there should not be any movement. If there should not be any movement, how can I balance it? By applying the anti-clockwise movement, isn't it?
Yes.
So if I apply some anti-clockwise movement, I am applying where? I am applying it movement at C towards B. Look at the joint B. It is continuous, isn't it?
Yes, sir.
If it is continuous, how much movement will carry over? Half of the movement will carry over. So first of all, I have to neutralize this support according to my support condition. Initially, I am considering that there is a +7.5 acting at the joint, but as far as I know, there should not be any movement developed at C. How can I make it as 0? By applying the movement at opposite direction. How much it will be? -7.5. As I'm telling you, if I am applying a movement at this point, what is the current? B.
B.
Is a continuous, half of them will carry over. So half of them will carry over to, so how much will be?
minus 7.5.
Divided by 2.
What about here? At A, moments will be there, isn't it? Will develop. So there is no need to make it as 0. Can you tell me how much you are getting? Minus 5. This is used up, I can write it down, plus 5. Can you just tell me about here?
3.75.
Total add these two values.
11.25.
7.5 minus 7.58. Minus 7.5 minus 7.58. How much?
0 minus 11.5.
Minus
11.25.
11.2. What about here?
0.
Now look at this joint B. Is there any externally applied moment just like we have discussed in the previous examples? No.
No, sir.
There are no external applied moment. If there is no external applied moment, then if we add both the moments, how much you should get?
0.
That's where the equilibrium is satisfied, isn't it?
Yes, sir.
These two plus 5 and minus 11.5. If we add these two, are they getting 0? No, isn't it?
Yes, sir.
So what is the unbalanced moment? There are two. Right? There is clockwise moment. On the other side, there is an anti-clockwise moment. Clockwise moment of 5, anti-clockwise moment of 11.25. So if we add these two values, how much we will get?
Minus 6.25.
Unbalanced moment 6.25. What is our motive? Our motive is to make it satisfy the equilibrium equations. According to the equilibrium equations, if you apply a moment at joint B or if you add summation of moments at joint B, it should get 0. But if you add these two, how much I am getting? I am getting an unbalanced moment of how much? 6.25. How can I make it balanced? According to our condition, if I apply a clockwise moment of 6, if I add all these values, can I get 0 or not? I will, right? So to make it satisfy the equilibrium equations, I have to add the additional moment of 6.25 at that joint. So if I am adding additional moment of 6.25, that should be again distributed to the corresponding members. How much will be distributed to the BA and how much will be distributed to the BC? Out of this 6.25, is it got it? Why I'm applying a clockwise moment of 6.25? Have you got it? Is it clear why I should apply or
Yes,
why
sir.
should I do correction 6.25 clockwise? Make it
Yes, sir.
equilibrium equation. Now what you should do, again it will distribute it to the corresponding members. So according to how distribution factors, what is the distribution factor for BA? Out of the 6.25, half of the will be taken care by BA and half of the will be taken care by BC. So how much will we go to the BA? That is nothing but half of this magnitude. How much? 0.5 into 3.25. 0.125. And here also it will be 3.125. So what is the distribution factor? 0.5. What is the distribution factor? 0.5. Now, again, if you look at this joint, if you're applying some correction at B towards C, what is the far end? C. What is the type of the support at far end? Pin support. If the far end is pin support, is there any carryover factor? 0. That's why movement won't be carried over here. But if you're applying some correction at BA, what about the support A? Fixed support. That means carryover factor will be there. How much it will be? 1/2. So out of this, half of the movement will be carryover. How much it will be? 1/2. If you solve this, how much you will get it? 3.15/2. How much? 1.625. 1.5625. Is it okay this step? Or if you want to write me in the form of table, this is the member AB, member BA, member BC, member CB. Carryover factor is area is how much? Half of. Directly I am writing from this step just for the easy purpose.
minus 5 plus 5 minus 11.25 0. As I am telling you, correction how much we should apply? 6.25. That will be distributed. How much? 3.125, 3.125. Again, it will be carry over. How much it will be? 3.125 by 2. Here, as it is a pin support, there is no carry over. Now, can you tell me how much you will get it? Add these two values and tell me how much you are getting. Minus 5 plus 3.125 by 2.
Minus 3.437.
Minus 3.4.
37.
Here I can say 8.125. And here, minus 8.125. Here it will be 0. Now see, add these two values, how much you are getting? 0. As they are getting 0, then you can say that moments are balanced or they are satisfied the equilibrium equations. That means these are your final end moments. Now, what are the final moments? What is the moment at A towards B? Minus 3.4. What is the moment at B towards A? 8.125. What is the moment at B towards C? Minus 8.125. What is the moment at C towards B? 0. After that, you guys know exactly what you should do. After this, what you guys have to do? You have to find the support reactions, and then you should find the force diagram, and then you have to draw the bending moment diagram if they ask you. As of now, any doubts?
Yes.
Now, if there is a overhanging, can you tell me how can I approach this? Just give a thought. How should I approach this? Already we have seen, right? See, the problem with any method, either moment distribution method or slope deflection method, is that if you add additional complexities, how you're gonna solve it? That's it. Already we have seen if it is a slope deflection method, if there is a overhanging, how do we have to encounter there? Similarly, can you tell me here?
Moment, sir.
Similarly, in this case, how you gonna approach this method? Like, just think about it. Moment distribution method I have to apply, where the differences will arise. We know, right? What is the known magnitude here? Moment at B towards C. What is the moment at B towards C?
20, sir.
20, sir.
20, right? Okay, now
And the
imagine.
20 will be carried between.
Let us say first case, second case. Hope you guys can solve the second case, isn't it? Can you solve the second difficulty in second case, or it's just the direct application of what we have discussed? Look at the second case and tell me, can we apply the same way what we have solved in the previously, or is there any difficulty in the second case?
No, sir, same.
Same as we have discussed, right?
Yes, sir.
Now look at the first case and tell me how can I approach in the first case. But I know that this case I can redraw this. Can you tell me how much moment will generate here? Anti-clockwise 20, 2 meter. And what about the reaction here? Upward.
10.
Yeah, 10, that is right, but because of the place constant, I'm drawing them again nicely. Let us, if I consider the free body diagram of the part BC, if it is 10, can I find the reactions here? As like already we have discussed, vertical force is balanced by here 10, and the length is 2 meter. And what about here? It is 20. And how much force we should consider here? If it is 10 upward, here you should consider it as a 10 downward. Here it is anti-clockwise, so here it will be clockwise. Now again add these two. Are we representing our original case or not? Always think about one thing, whenever, it doesn't matter wherever you separate, if you combine them, is it representing the original case or not? Now imagine, combine these two and look at the original diagram, clockwise and anti-clockwise. What is the net value? 0. downward, what is 0, and the original case, that's right.
Yes, sir.
Now, wherever there is a overhanging, what I will do, I will omit this part BC. Why? Because I have already known my moments and or I can easily find out my shear force diagram, bending moment diagram here. So that's why whenever there is a cantilever part, first of all, the first thing you have to do is separate the cantilever part and then apply the moment distribution method for this part. Now,
Still, what is the difference that will still make an? Now tell me, in first case and look at second case, what is the difference that you guys observe there? Observe the difference between the first case moment distribution method part and the second case moment distribution method part, where you guys can find the difference there.
At
I am
joint, there is a moment acting, sir. We have
at
to
joint, there is a
consider
moment.
as 20.
Yeah, that I'm just asking a question so that if you guys answer so that I can explain in that way so that it will be nice to understand. Now, if you understand the first case and second case, the difference is that in first case, there is a moment that is developing at the joint. In the second case, there is no moment developing at the joint. So in the second case, how you will apply the corrections or how you will like what is the equilibrium conditions that you will consider at joint B? In second case, what is the equilibrium equation at joint B that you consider?
Slope at A equal to 0.
No. Moment distribution method. If you are talking about moment distribution method, when you will stop it, when you will identify that whatever the moment that you have got
And
is
ED should be the same moment, sir.
moment.
Moment at BA and BD.
But A and BD equal to 0.
It's not same. You can say that the summation of moments at joint B is equal to 0
0.
in the
Okay.
second case. Where is the exemption? The exemption is that where you are having the additional moments or joint moments. In the second case, there are no additional moments at the joints. That's why if you add the moments at the joint, you will consider them as 0. But look at the first case.
20, we have to consider 20.
Right. So what is the difference that we have to consider in the first case? In the first case, what you should do? What is the equilibrium equation that you have to consider? If you
BA
add
plus
the
BD
summation of
equal to
moments,
20.
if you add MBA plus MBD, that should be equal to how much?
20.
Here the direction is clockwise. That's why 20. The more direction is anti-clockwise, you have to make them equal to minus 20. So in the previous case, we have done summation of moments equal to 0. That's how we have find the unbalanced moment and then distributed. But in the first case, as there is a concentrated moment at the joint, what we should do? We have to take summation of moment at the joint is equal to 20, and based on that assumption, you have to find out the, or you have to do the iterations until and unless your summation of moments are exactly equal to 0. Is it clear? Where the difference will come if there is a overhanging part? Is it okay now?
When you go to the previous slide, sir,
Yeah.
the first iterations we did, I'll copy, sir.
So what you can do, you whatever these two example, like with cantilever, without cantilever, you guys solve these two problems and then we'll continue in the by tomorrow. Hope it won't take not more than 30 minutes. Just solve it until the final line moment. That will be more than enough.
So the previous slide, sir. 1 minute, sir.
have you got understood the methodology? First of all, if you understood the methodology, then that is fine. Okay, shall we stop now?
Yes, sir.
Okay, solve these cases, solve these two. If you have any doubts, let me know. We'll discuss it then. Okay.
Yes, sir.
Okay. Thank you, guys. Bye.
Thank you, sir.
Thank you, sir.